take a look at finding values x and y that satisfy a matrix equation when it's already in the augmented matrix. It's already set up in an augmented matrix. So we're going to continue to multiply, and it's under the title of matrix multiplication. So as you remember from the last video, we're going to multiply the first row by the first column. In this case, we only have one column, so we're going to multiply these two together. Let's go ahead and set up our answer matrix. That's going to be a 2 by 2 times a 2 by 1, which means that the outside dimensions tell me my answer matrix. So I'm going to have a 2 by 1. Alright, and that's going to still be equal to this 2 by 1. Well, that makes sense, right? Okay, and then we'll be able to pull them, the entries out and set them equal. So we have 2 times x plus 4 times y. Take the first one times the first one, second one times the second one, right? And that's not two separate entries, right? That's one entry. It's a binomial. Okay, let's take a look at the next one. This one times this. Once we finish with the first row and all of the columns, which in this case is just one, then we move to the second row. So we have 1 times x plus, the next one in line would be 3 and y, so 3y, and there we go. So now we have this top one is set equal to that one, so we'll create the equation that is not a matrix. Okay, there's that. And then we have, of course, this is equal to that, right? Each entry has to be equal because we see the equal sign. So corresponding entries, again, they have to be equal. Plus 3y is negative 22. Alright, so now we're ready to solve this. And you notice that, well, this example, I'm not going to use a graphing calculator. Okay, so I'm showing you, we'll do graphing calculator ones later, but we do have to know how to solve these just the good old-fashioned way, by hand. You could solve this by Gaussian elimination. We could solve this by hand. We could solve this by elimination. We could solve it by substitution. I think I'm going to go ahead and just use substitution. Pardon me, let me go back to elimination. I'm going to use elimination. So anyway, let's take a look. I'm going to multiply this by negative 2. And that's going to give me negative 2x minus 6y is equal to 44. Alright, so let me go ahead and eliminate one of the columns, which would be this column here, which is nothing. This column here would be negative 2y. And I'm going to add this column here, which, by the way, is not using this. So I get, is that a positive 14? So I'm going to divide by negative 2, and I get negative 7. So now I'm going to use substitution, bring that back in, probably just to the top. Why not? Top equation, and solve for the other variable. 2x, that's minus 28, so I'm going to go plus 28, and that's going to give me negative 2, so x is going to be a negative 1. So my answer is negative 1, negative 7. Now let me go ahead and make sure that that really does look correct. I'm going to put this back in the x and this back in the y, just visually. Have negative 1 there, and I have a negative 7 there. So that's negative 2 plus negative 28. Check. Let's put it in the next one. Negative 1 there, and that's going to be a negative 7 there. So I have negative 1 minus 21, and that's negative 22. Check. Okay, so doesn't take long to double check myself there. Alright, so let's take a look at one more example. Now this is going the other direction. Find the following system, write the following system, as an equivalent matrix equation in the form of AX equals B. Notice it doesn't say to solve it. Let's look at the directions here, up here. Find the values that satisfy the matrix equation. Well, the X and the Y values definitely satisfied the matrix equation. This doesn't tell me to solve anything, so I'm going to go ahead and make sure that I follow the directions and save some time if I can, right? There's 3, 1. I'm just taking the coefficients off. Now, if you notice, this one is not ready. So let me adjust that a little bit. I need the 6x on the other side. That's a y that's positive, and then now it's equal to 50. So now I'll put this one in its proper spot. So I have a negative 6 and a 1. So there are my coefficient. Okay, that's my coefficient matrix. Now let me write my variable matrix, which is right here. That's my variable matrix. And then, of course, the last one on the other side of the equals is my constant matrix. No variables involved. It's the constants. It's the 5 and the 50. All right, coefficient, variable, and constant. Let me write that, constant. Pardon me. All right, so let me check my work here. I have a 3, a 1. I pulled the 6x over. That gives it a negative 6. There's a 1, and there's 50. All right, so it doesn't tell me to do anything else, so just follow the directions, and we're finished with that, right? Thanks for watching.